this unit, we're going to talk about conditional statements. We have an if-then statement, and we have an if and then our hypothesis, and then a conclusion. So let's identify in this next conditional statement what the hypothesis is, which comes after the if. So it would be that the sun is shining. Our conditional conclusion on the conditional statement is after the then. So then it must be daytime. So we're going to go ahead and label our hypothesis with a 1 underline and 2 for our conclusion. So a number is a whole number is our hypothesis, and then it is an integer is our conclusion. Now in this next statement, you see the if right here. So this would be my hypothesis. We underline that once. And then over here, we're going to underline that twice. So we're going to next write what's called the converse. And the converse just switches the hypothesis and the conclusion. So it has the conclusion come after the if, and then after the then is the hypothesis. That's called the converse. So here's our original conditional statement. If a number is divisible by 3, then it is odd. So is every number that's divisible by 3 odd? Well, a number is, if it's divisible by 3, then it's odd. We have a false statement there because we could have the number 30. 30 is divisible by 3, but 30 is even, so that would be false. So that's kind of what a counterexample is. It's just an example that proves that statement is not true. So we can write a converse by switching. So we would say if a number is odd, then it is divisible by 3. So we would look to see for any and every odd number, if those are divisible by 3, to try and come up with a counterexample, because if we can come up with a counterexample, then we know it is false. And we could think of 17. 17 is an odd number, but it is not divisible by 3. So that would be a counterexample. So can we write a biconditional? And the only way we can write a biconditional is if these are both true. So we cannot. And we'll talk about more about that, and we will actually write one after we get through the rest of these. So if a triangle has a 90-degree angle, then it is a right triangle. So that would be true. As a right angle in a triangle makes it a right triangle. So let's go the other way and take and put the if a triangle is right, or if it is a right triangle, let's put that. It's hard sometimes to make it sound like proper English. If it is a right triangle, we could just keep it like it says it there, then it has a 90-degree angle. There we go. And that is true. If it's a right triangle, it's going to have a 90-degree angle. So since both of those are true, we could write one, and we'll do that in a little bit after we talk about what that means. But let's continue on with our converse writing. If a quadrilateral has sides of equal length, then the quadrilateral is a square. So that is false, because we could have a rhombus. So rhombus has 4 sides but that are equal in length, but it is not a square. So that is false. So if we wrote our converse, it would be if the quadrilateral is a square, then it has equal side lengths. And that is true. But we cannot write a biconditional if that's false and that's true. So our next statement here, if x equals 3, then x squared is 9. So that would be true, since when we square 3, we get 9. Okay, so if x squared equals 9, then x must equal 3. Well, if that first part is true, then x could not only equal 3, but it could also equal -3, because -3 times -3 is 9 as well. So it doesn't always have to just be +3. So that is false. X could equal -3, and it's still, that first part, be true. So no biconditional for that one. So let's talk about a biconditional. A biconditional is written when it's just one sentence, and we use if and only if. And you can write that at the beginning, you can write it in the middle between the two statements, but most of the time it's written in between. So let's take a look at this example. If a triangle has 3 sides of different lengths, then it's a scaling triangle. That's true. If it's a scaling triangle, then it has 3 sides of different lengths. That's true. So they took the first kind of part and then the last part, but then in the middle, instead of having an if and a then, they just put if and only if in the middle. So we're going to go back to the if and only, the biconditional, and write if and only if statement next to our yeses. So we have one yes. So we're going to come up here to this one. So every definition, you can write a biconditional statement, and that's what this is right here, a right triangle's definition. So we are going to write, it is a right triangle, and it doesn't matter which one, if you put the hypothesis or the conclusion first, because it can go both directions, as we saw up here with the original and the converse, which is why you can add the if and only if in the middle there. So it's a right triangle if and only if it has a 90-degree angle. Okay, so that's how we write a biconditional statement, and we can only do that if it's next to a yes, meaning both the conditional and converse are both true. One last thing I wanted to talk about is we were getting pretty good at writing whether or not something was true or false, whether we had a counterexample. The only one that's kind of weird is if we have a hypothesis that is false, comma, and a conclusion that is false. The statement as a whole is true. So I always think of like 2 wrongs don't make a right, but a false makes a true. So, for example, if I'm invisible, which most people know I'm not invisible, so that's false, comma, then it is December, and we know it's not December. So both of those being false means that this statement is true. So that's the only kind of weird thing. Otherwise, if you can think of a counterexample, then you know the whole statement. It's either true or false. But just kind of wanted to throw that out there in case you see that at some point, which you will, on one of your questions for your homework.